think I lost them. Huh? They're here. Step into the glitzy, dangerous world of Hollow Promises, a 1920s murder mystery game brimming with jazz, betrayal, and deceit. You play as a private detective tasked with solving the high-profile murder of Victor Sinclair, the ruthless owner of the Velvet Room Speakeasy, found dead in his luxurious Beaumont hotel suite. Explore the crime scene, piecing together the night's events from blood trails in the bathroom to a disheveled office, where a damning business ledger and cryptic lyrics hint at motives steeped in revenge. The sultry jazz singer Evelyn Thibodeau, once Sinclair's lover, croons nightly at the Velvet Room, her voice laced with the sorrow that conceals far more than it reveals. The wealthy socialite Vivian Hargrave, desperate to protect her family's name, whispers half-truths, while Tobias Kingsley, the embittered bootlegger, fumes over broken contracts and broken bottles. Interrogate suspects, uncover buried secrets, and tread carefully, as every choice edges you closer to the killer, or deeper into danger. The lush hotel halls pulse with an air of menace, where every note of jazz and every sideways glance could be your next clue. The truth lies in the shadows. Will you uncover it before it's too late?
I was responsible for creating the clue interaction system and the clue journal. Clue interaction is one of the core mechanics of our game. It's what allows the player to collect clues around the map and add them to their clue journal so they can get more information about what happened. The clue interaction system is made using Unreal's blueprint system and is based on an inventory system I had made for a previous game. I also worked on creating the clue journal, which is what allows the player to actually view the clues they've collected. We chose to use a 3D model to store all of the clue information instead of a more traditional UI menu, because we felt that it better fit the technology we're using with the Tilt 5, so we could take advantage of the holographic effects. All of the modeling and animation for the journal were done in Blender, and the texturing was done in Substance 3D.
I'm Cora, and I was responsible for creating an immersive, historically accurate experience in the game. I used Fab to compile and composite all the assets in Unreal Engine 5 to create the scenic design for the level, ensuring every detail contributed to the setting with accuracy to the era and the story we were telling. A large component being the investigation of clues, I worked to curate an engaging but effective collection of clue assets that I retextured and mindfully placed in conjunction with the actual crime scene and weapon, based on where the characters would have been throughout the room. For the suspect portraits, I used Photoshop's generative AI to turn our metahumans into actual characters, focusing on costuming and background to round out their personalities. After capturing the photos of the clues, I recolored them to highlight the emphasis of the photo. Finally, I layered in a soundscape of footsteps and authentic public domain gramophone music from the actual 1920s to tie it all together, adding depth to the ambiance and the setting. My goal was to give our setting all the components it needed to become a visually stunning and immersive interactive experience.
The parts of this project that I worked on include creating the metahuman that we used as our main character, as well as all the metahumans featured in the photos on our suspect board, creating the clothes for our metahuman using Style 3D, working within MetaTailor to assign clothes to the metahuman, and creating the pages for the journal. I created the metahumans using the pre-made metahuman features and exported our main character to Style 3D when I was ready to add the custom clothing. For the clothing, I used a program called Style 3D, which I kind of had to teach myself to use since there are not many tutorials available. I started by looking for a sewing pattern for the type of clothes I wanted to make, and from there I could trace the patterns to create the pieces of fabric that I would then sew together using the segment and free sewing tools. Once the garment had been sewn together, I was then able to simulate it and see how the clothes fit the metahuman body and adjust it as needed. Then I used MetaTailor to assign the custom clothing to the metahuman so that they would show up on the body in Unreal. Once the body is clothed and in Unreal, I needed to reassign the base skeleton to the third-person skeleton by creating virtual bones that would allow the character to move with the controls. I then saw that I was getting a lot of clipping with the custom clothes and discovered that I could use Chaos plugins to fix that a little bit. Then I put together the pages for the journal on Photoshop using the edited pictures of the metahumans and the character clue descriptions from Cora.
For our final project, we decided to do an underwater scene in VR. The scene is made in Unreal Engine and includes several interactions in which the player is able to explore their environment. Our process video will guide you through the creation process of making this interactive experience using megascans, metahumans, Unreal Engine blueprints, and sequence nodes.
To create this interactive underwater experience, I began by leveraging an existing blueprint, which I found online, and that featured basic water simulation and animated 2D fish. Using this as a foundation, I enhanced and customized the environment to achieve a more immersive and realistic ocean bed scene. So the first step was basically to refine the environmental settings. I adjusted the lighting to create natural gradients and also modified the fog density and color and fine-tuned the volumetric god rays within Unreal Engine to simulate the dynamic interplay of light kind of penetrating through the water. And these changes really established a sense of depth and atmosphere, which is definitely essential for a convincing underwater setting. With the foundational environment in place, I incorporated high-quality assets from Bridge, the megascans that were available there, and also from Sketchfab. These assets included seaweed, kelp, aquatic plants, diverse rock formations and various other seabed elements, such as rusted pipes and other debris. So the strategic placement of these assets was what ensured like a cohesive and visually compelling layout. The interactive components of the project were developed using Unreal Engine's blueprint system. I basically began by testing trigger boxes and refining like the associated scripts to ensure seamless functionality. Once the mechanics of those trigger boxes were established, I was able to implement a series of dynamic events. One of the trigger boxes activates a school of animated fish brought to life using a level sequence that reacts to the player's movement. So when the player enters the trigger box, the trigger detects uh, the player's entrance and then starts that sequence of those fish. Another trigger initiates a dramatic shark animation, creating an unexpected and engaging moment for the user. This project really demonstrates the power of Unreal Engine's tool set in crafting like visually stunning interactive VR experiences.
In the project, we wanted to add a character that would be the player's companion and follow them throughout the underwater experience. I created this character using a custom metahuman and importing the model into Blender for adding textures and detail. I retextured the skin of the metahuman to look like a scuba diving suit. Since scuba suits are generally pretty skin tight, I didn't have to model anything extra onto the metahuman's body. However, I did create a helmet model for the scuba player, which I also textured, as well as some swimming flippers that would replace the default metahuman ones. Once I was done retexturing the metahuman in Blender, I exported all of the material files and skeletal meshes into Unreal Engine. In Unreal Engine, I went about updating the metahuman blueprint by going into the texture assets and replacing the default ones with the custom ones that I just created. I replaced the skeletal mesh of the shoes with the skeletal mesh of my swing flippers and added the helmet into a head socket for the metahuman so that the helmet would constantly track on the character's head along with their animations. We wanted this character to act as the player's companion, which means we needed to follow the player's location in VR. Motion capturing for swimming would be pretty difficult without a harness, so we found two separate Miximo animations which would help bring this character to life. I imported both of these animations into Unreal and created a blend space for the animations to seamlessly transition from the idle in place swimming animation to the more dynamic swimming forward animation. I added this to an animation blueprint and attached it to the metahuman so that the animation blueprint would change animations based on the character's moving speed. Then, so that the character could follow the player, I added two separate node events to the original blueprint. The first was the begin play event, which would trigger the character's idle animation as well as trigger the first instance of the follow VR player event. The follow VR player event loops into itself and has a simple AI move to that gets the player's location inside the underwater scene and moves the character to a relatively close distance to the player.
Hi, this is Lauren. I was responsible for designing, modeling, and animating some of the fish you see swimming around in the background of the interactive simulation. I really enjoyed this process, and I thought it was super fun. Getting to figure out the different armatures for the different sea creatures. It was a bit of a challenge, but it was fun, like, figuring everything out and getting the different parts of the fish to move. Is satisfying to see it fully animated and, swimming around like a real fish. I made this model completely from scratch, as did some of the other models. And it was just a really fun process. And here you can see me adding the armature to this one.
Thanks for coming all the way over here. I know it was a long journey to London. We wanted to give you a quick brief before we send you unattended into the tunnels underneath the city. We had a bad last run-in with the cops, so we won't be able to join you on this mission.
Don't forget, we're paying you big time. Don't fuck up like the last guy.
What you're gonna need to find is this. It has to be this specific medallion, so pay attention. The medallion you are being sent to receive is said to be the key to the hidden vault deep inside the Temple of Horus at the Egyptian pyramids. Don't go digging amongst the other treasures down there. You'll find yourself in some trouble if you take too long to get out. The catacombs were designed to keep out unwanted visitors and protect the precious items they hid inside.
Not to scare you, but no one has ever ventured this far inside successfully and lived to tell about it. I'm not sure what you might see when you're down there, but don't let the walls play tricks on you. Make it out in a timely fashion, because staying down there too long can cause you to go crazy.
Are you ready?
To make the animation cutscene that runs at the beginning of gameplay, I started by building the scene, combining multiple assets and textures from Fab. For some assets, I edited the mesh and added new textures. The lighting gives dimension to the room, bringing attention to the characters while also remaining cohesive with the map. We each designed one of the metahumans, making sure they had different characteristics to make a realistic expedition group. Zane's body animation was a motion capture I filmed with a Rococo suit. I baked him to a control rig and fixed up the animation by adjusting the rig and setting keys. For his face, I used the LiveLink Face app and processed the footage in Unreal to create an animation compatible with metahumans. I also baked that to a control rig to adjust the animation. Both of the women, Laura and Max, were animated using Mixamo, and their face animations and voices were also created using processed footage from the app. They're both baked to control rigs on the face and body. For the user interface, I started out in Photoshop, creating the menu elements from scratch. Once I was done with that, I was able to create a widget blueprint and import the assets. I actually had to make 6 button images since the start and the quit each have an image for when it's regular, hovered over, and then clicked on. In the widget blueprint nodes, I coded the quit button to exit the game and the begin button to trigger you to the animation level, starting the game. There are actually triggers coded in each level to take you to the next. To actually put the widget menu into the game instead of attached to the viewport, I had to create a widget actor class to drop it in the map.
The look and atmosphere of the map and game were inspired by the catacombs and their maze-like orientation. We wanted to use various textures and assets to put our own spin on things and create an underground dungeon experience. The majority of the assets were pulled from Fab, and the layout of the walls were made in Blender, where we created a confusing yet winnable layout for the second level. We wanted to change the controls of the VR pawn for a more realistic player experience. This involved changing the movement method from teleportation to free locomotion. To increase immersivity of the gameplay, we thought a joystick control would be beneficial to making the player feel like they were actually inside the game. We kept the same idea when changing the rotation to a free rotation instead of a clicking mechanism. This allowed the player to more easily turn around corners and explore the map in a natural way. We also included a sprint mechanic where the player can hold the joystick down to run faster, allowing them to outrun enemies in the second map. I created a realistic working door for some interaction between elements in the first level. The door works with a lock and key, meaning the player must find the correct key and insert it into the keyhole located behind the lock asset. The door cannot be opened prior to inserting the key. It works realistically, meaning that if the key is removed while the door is open, the door can still swing around until it is shut. If the player then tries to open the door while the key is not inside the lock, it is impossible to grab. The key is also associated with the sound, indicating to the player the door is open and movable. To keep it even more realistic, I made it so that the door can only be grabbed and manipulated from the handle. The key also follows a spline on the keyhole blueprint, meaning it clicks and follows a line to properly be fully connected into the lock. For the enemy, we created an AI movement system, meaning the enemy freely walks around on its own inside of our navigation mesh. It relocates itself every few seconds, patrolling around the map looking for a player. When the enemy locates the player in its line of sight, it transitions from a walk to a run and actually speeds up to catch the player. It will chase said player until they are out of its line of sight for at least 2 seconds, and then will revert back to patrolling. We chose fitting animations for when the enemy is walking versus running to increase player fear or interaction with the enemy. We also choose to use sound localization so the player can be aware if they are close to an enemy. There are 2 sounds, one with a larger radius that can be heard farther away, and then another that happens if you are scarily close to being killed by one. We used the capsule component we created for the enemy to trigger the player into a jump scare. We used an animation that appeared to be eating the player so that when sent to the jump scare, the enemy is right up close to the player's face. Instead of sending the player to a new level, the VR pawn view is switched to a Cinecamera actor programmed with the jump scare sequence. This sequence is coupled by discontinuing the input of both controllers, meaning the player cannot run away.